Now let's look at two situations. Here we have a curve which is concave up like this, and here we are going to have a curve which is concave down like this. Let's look at the derivative, the slope at different points. So here the derivative is negative. Here it's equal to 0. And here it's positive. And I'm just going to call this point x1. And here at x2, it's also positive. And also what we can say is that because the slope here is greater than the slope here, where we have x prime of x2, which is greater than f prime of x1. So basically, f prime here is increasing all the way from this point to this point, where it was negative, it becomes 0, and then it's a bit positive, and then it becomes even more positive. Well, if f prime is increasing all the way, that means that f2 prime, which is the second derivative of x, must be positive. So, okay, basically it's concave up. So when a function is concave up, the graph of a function is concave up, that means that f2 prime must be positive, and vice versa. Well, I can do the same kind of analysis for this one, which is concave down. And so here, okay, let's do the analysis again. Here we have f prime, which is positive. Here it's equal to 0. And then here it's a bit negative. And if we kind of looked a bit further at x2, it's more negative because it's the slope is greater, and so f prime of x2 is less than f prime of x1 because it's more negative than f prime of x1. So that means that f prime is decreasing all the way. And because it's decreasing all the way, that means that f2 prime must be negative. So if the function is concave down, that means that f2 prime must be negative. f2 prime positive, concave up, f prime negative, concave down. Let's do an example. Say, okay, so we have f of x, which is x cubed minus 3x squared plus 6x plus 3, and we want to find the value for which it is concave up or down. Okay, so the first derivative, it's 3x squared minus 6x plus 6. The second derivative is equal to 6x minus 6, which factorizes 6x minus 1. So, when x is less than 1, f2 prime of x is negative, and so the curve is concave down. Whereas when x greater than 1, f2 prime of x is positive, so the curve is concave up. Okay, what are the value? Okay, so for which value is actually f prime is equal to 0? We have an extremum. So f prime of x is equal to 0 means that 3x squared minus xx plus 6 equals 0, which means that x squared minus 2x plus 2 equals 0. And what are these roots? Okay, so the roots are so delta is b squared 4 minus 4 times 2, which is negative, so there are no roots. Okay. Right. So that means that, okay, so we can do a kind of a little table summarizing what the function is doing. So what are the specific values? The domain is between plus infinity and minus infinity, and there is one specific value for which is x equal 1. Okay, so f2 prime. Okay, so f2 prime equal to 0 when x equal 1. Below that, f2 prime is negative, and here it's positive. F prime of x, so there are no roots, and basically for whatever values of x, it's always positive. So what is x going to look like when f tends towards minus infinity? It's going to tend towards minus infinity, plus infinity, plus infinity. So it's going to be increasing like this. And there is a specific, at that point, x equal 1, we could calculate the value of f of 1 here. Yeah, and actually if I plug that in the calculator, f of 1, I found 7. And so the graph is going to look like that. So 1, 7, okay, not very, and it's going to look like that. There you go.